Well, I'm tired of laying down law. You don't care to listen, you don't care at all, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me for what you need, yeah. The first time I trouble, you're gone to the devil, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. And I'm tired of breaking down the wall. You just keep your distance, and you don't care to call, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me for what you need, yeah. First time I trouble, you're gone in the double, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. Come on, boy! And I'm tired of waiting for the fall, and you make no commitments, you can't have it all, and you don't understand as to what it means to be with a man like me, yeah. Treat me kind with love all the time and tell me what you need, yeah. First time I trouble, you're gone on the double, and I don't mean to burst your bubble, but I love you, and now I'm gonna miss you, and bye-bye. Take it home, boys! Come on! And I'm tired.
Sorry about that. All right, there you go. It should be fixed now. Anyway, just to review what we were doing last time is we wanted to support this financial application system, and we decided ultimately let's keep it simple and have a single table inheritance strategy. Again, this is a table per subclass strategy. This is a table per class strategy. And both of them are completely valid strategies. It's just that it's going to be a lot more work, right? And I don't want to do that work. So to get started, let's go ahead and start, whiteboarding this. This is my whiteboard right now, right? It's just my good notes on my iPad here, okay? So help me out. Where should we start? Let's do the obvious things first. The obvious thing is sitting over here, a person table, right? So let's go ahead and create a table over here. Ultimately, we're just going to sketch this out. And for your next design document, that's all we expect, that you sketch this out. Ultimately, you're going to implement your database, dump this to an ER diagram using MySQL Workbench or some other tool, and then replace your sketch with something that looks like that, okay? So let's make this into a person table. Did I call it the persons table, or the people table, or the people's table? Nope, don't pluralize anything. English is a terrible language when it comes to pluralization rules. Stay out of those weeds by simply keeping everything single, right? That's what we did over here with Java anyway. Right? Why do you think I called it person with a capital P? Because that's what my table's called. Or that's what my POJO is called. Plain old Java object is called. Right? If you maintain a one-to-one mapping from your POJOs, plain old Java objects, to your tables, you're going to have such an easier time. You never have to remember anything ever again, right? I have a first name, last name, right? There's a one-to-one mapping between everything. So that kind of suggests what we're going to do in this table, right? All you have to do is look at the UML diagram, and we're probably going to have a first name and a last name, both strings. Probably want a date of birth. I'll have to think about that one. Probably want emails. But before I even begin, what's the first thing I should do? What is the first thing in every single one of these tables? What is that again? That little yellow thing? A key. And it's a primary key, and it's an integer. So I'm going to do the same thing here. Person ID. Primary key, and it's an integer. Those are just notes to myself. Right? This is not SQL code yet. Why did I immediately jump to person ID like that? Lower camel cased, right? And it's named after the table. No guesswork here, okay? Otherwise, first name, last name. It's just a sketch, so I don't even have to follow my own conventions here. But these are both going to be clearly varchars. 255 probably, but you can use the keyword string in some variants, but I'll go ahead and keep them as varchars. What did varchar stand for? Variable characters. Right? In other words, a string. Okay. What else do we have? Date of birth. Date of birth. Okay. How did we do that in Java over there? We used a class, right? A local date class, right? Not a string. So you might ask yourself, well, is there such a thing in SQL? Yes, there is. It's called date. It is not interoperable. It is not compatible with most systems. Don't use it. Right? Instead, let's be proper computer scientists and use a string. Is this a proper computer science string? March, what is today? 8th? 2023? Yeah, nope. Is this a proper computer science string? It is March 8th, 2023. Oops. Also, why? It's not lexicographically orderable. The only correct way of doing this is 2023, 0308. Padded out with zeros. That's an ISO 8601 properly formatted string. Right? Why? There's no guesswork there at all. It is completely lexicographic according to the major order. The years come first, then the month, then the day. General to specific. Right? All right. So in other words, it's going to be a varchar of that form. How many characters am I going to need? 1, 2, 3, 4. 5, 6, 7, 8, 9, 10. Right? So probably a varchar 10. That's another reason that you put in leading zeros. Right? But not only is it lexicographically correct and orderable, but also it makes everything nicely uniform. Right? Everything is going to be 10 characters, period. Okay. What about the emails? Should I start to do this? Email, well, I need to support email 1, email 2, email 3. Hand it in. It breaks when somebody has an email 4. Okay. Email 4. Hand it in. It breaks again. Just keep adding until it passes the grader. Don't do that. Right? Because that just tempts me to go back in and make sure that there's at least one person in there with 50 emails just to break your code. Right? So, one person could have 0 emails. Right? If we had just the first one set, right, and then the other ones are kind of wasted, why do you have those columns to begin with? That's what's called a violation of first normal form. We'll get into what normal forms are after we've done this. First normal form, second normal form, third normal form is everything must be based on the key, the whole key, and nothing but the key, so help me COD. COD being Edgar COD. Right? So everything must be based on the key, the whole key, and nothing but the key. Right? All right. So how do we do this? You want a list of strings. Well, how did we do this in this database over here? One publisher could publish many games. One person could have many emails. How did we do that relationship? Another table. So probably on, on email table. And being consistent about it, what's the first thing I should do? Email ID, primary key, which is an integer. Right, there we go. Right. What's the relationship between these two tables? Let me move it down. A one to many in that direction. One email has many people. You never want to share your email, right, with anybody. Right. Too risky. There we go. Nice and straight. One person has many emails. That little chicken foot there is what's telling you that it's many. It's 1, 2, 3, right? Many. Sometimes you'll see like a 1 explicitly put over here and then an M over here. Right? I don't like that. Right? Okay. What else belongs in the email table? The actual email, right? So should I call it email? Probably not. Call it maybe an address. And what type should that be? Is there a built-in email type? Probably not, right? So it's probably going to be a varchar. 1970, do you think email existed yet? That's a good question. When was SMTP first invented? Right. Here's a little history lesson. SMTP history first invented or first developed. Is anybody else? Oh, it's early 70s. Right. So yeah, it was on ARPANET. In November of '81, he published the RFC. Okay. Yeah, they had things like that back in the 60s, but not modern email, not SMTP. Simple Mail Transfer Protocol is what we call it. That's what email is. Right. Okay, so back when I asked that because back when Edgar Cod was putting this together, do you think that he built in email? No, because it really didn't exist yet. Right. So address varchar. All right, so say that I've got an address, edgarcod@ibm.com, right? How do I know that it belongs to Edgar Cod over here in the person table? How do I know that a game over here was published by this publisher over here? Remember, it's a parent-child relationship. So how does a child know who their parent is? This thing right here. This publisher ID refers back to this publisher up here, right? So where should I put that's called a foreign key, FK for short. Where do I put that here? Do I put it in this table right here, or do I put it in this table over here? What if I put it over here? Email ID. That tells me that Edgar Cod has this email over in this table. Does that sound like a one-to-many relationship to you? Nope, that sounds like he's got one email and one email only. So it belongs in the child table. Person ID. Why did I immediately call it person ID? Because that's what it is over here. Right? Again, if you're following your naming conventions, there's no guesswork here at all. You name primary keys after the table that they're in. You name foreign keys after the primary keys that they're referencing. Okay? That's a good start. Let's go ahead and start writing some actual code. Right? So how do you think you create tables? Create table, right? Person. Just what it says in the box there. Right? So create table and call it person. Here's my sketch. I need a person ID, first name, last name, and date of birth. So person ID. It's going to be a integer. You can write integer. You can write int. You can write integer, all caps. Why get fancy? Int. Right? Person ID int, not null, primary key, auto increment. There, comma. I didn't spell increment right. Increment. There we go. Now it's blue. Now I know that I spelled it right. All right, it's person ID. It's an integer. It's not going to be allowed to be null. By default, everything is null, right? By default, all values are nullable, right? They can have a null value, right? Not null specifies that they cannot be nullable, right? And that's a good thing because this is a primary key. It means it's going to be automatically unique because I've labeled this as a primary key. You could have a single person with a primary key of null, but nobody else could have that primary key. Right? It's kind of useless. So we're not going to allow it to be null because there'd only be one. But also we're going to let the database take care of itself. Do you remember when we inserted a game and inserted another game? We could hard code it if we want. It would have rejected it if there was already a duplicate value. But if I don't specify one will be provided for me. Just like that. And the way that you do that is through auto increment. Auto underscore increment. Primary key is 2 words. Not null is 2 words. Don't ask me why it's not auto increment. That's just not what they did. I think it's because it's an internal database value. At the end of each line goes a comma because it's just like an enumerated type in C. This first one, the second column, the third column, the fourth column. The next column is going to be first name, and it's a varchar, 255. Nobody's name is going to be 255 characters long. That's probably large enough, long enough. You could probably kick it down, 100 if you really wanted to. But what happens when somebody does have a first name, a very long first name of 105 characters? Those last 5 characters get truncated off and thrown away. 255 is for historic reasons. It's 1 less than 256, right? Because a null terminating character. And 256 is a perfect power of 2, 2 to the 8th, and 8 is a perfect byte, right? 8 bits to a byte. That's why. It worked out back then, right? We don't have that concern today, but you'll still see 255, 255, 255, just because people got in the habit 50 years ago, right? All right. Last name, varchar, 255. Now, by default, these are all nullable. Should they be? Should we allow a person into our database with no last name and no first name? I don't know. If you don't want that, then not null. Right? Maybe I'll go halfway here. Well, they have to have a last name because they have to have some name, family name, legally. But they don't have to have a first name, Prince, Madonna. All right. If I had redone the albums database, I would have done something like this. But I don't know. I think there are cultures out there where there's a family name but not a first name. Right? There are cultures where you've got a native name and then you pick an Americanized name and go by that, right? Because no Americans can pronounce your name, right? So people do that all the time. Weird things happen with names. Nicknames, right? Surnames, suffixes, prefixes, all that stuff. Don't worry about it, right? So the first name here is allowed to be null, question mark, to do, reconsider this. Right? I just put that into a comment here for me to come back and consider that. In fact, I like to align things here, so there we go. Right? I'm just showing this to you for variety. Something can be null, something might not be null. What else do we want in our person table? Date of birth. Date of birth. Varchar. I already said that it was 10. Why? Because it's a proper ISO date. Not null, but here I'm going to add something else just to show you the syntax for it. Default of 00000000. There we go. Now that's not an actual date. If you insert a person record, right, and it's not allowed to be null, that means that you have to provide the actual date. Unless you define a default value, in which case that default will be inserted for you when you insert something. Now, when you pull this out of the database and try to, marshal it into a local date, it's not going to work because that's not a real date. Likewise, February 30th, 2023 is not a real date. You'll end up having an exception, at which point you will know that there is data in my database that is wrong. On the front end, then I can display instead of 00000, I could display date of birth missing, right, in big red bold letters, telling the bank worker or whatever that you need to check into this further, right? But on the back end here in the database, I'll go ahead and store it as this flag value, right? Default flag value. That looks good for my person table. What about there was a great question in the first section here. Can you in fact enforce good data? Can you enforce that February 30th is not a valid date, not in the database, unless you use date instead? Right? And don't do that. It's not interoperable. Right? Okay. What else do we want now? Email table. And if I created the table with person with create table person, create table email. Oops. Email. There we go. Note there that those are parentheses, not brackets, not square brackets or anything. And then at the end, there is a semicolon here. Right. What's the first thing I should do? I shouldn't copy pasta, but I am. Email ID. Int, not null, primary key, auto increment. Just type that out, type that out, type that out. There, I just copy pasted. Okay. That takes care of my primary key. What about the address here? Address, varchar. I'll go with 255 here as well. Another question is, are you able to enforce some sort of a constraint here that only has valid emails? A valid email being, letters, followed by an @ sign, followed by a domain, right? Not easily. In fact, if you try to do this with a regular expression, I don't think that there's any one regular expression that would do that, because I think you can prove that it's not a regular language that's defined by the standard. In any case, don't worry about it, right? We just have an address in there. By default, though, we're allowing it to be null. Should I? So you've got a person record. If you want to show that this person has no emails, then you just don't have anything over here in the email table. You have a 1 to 0 relationship for that particular record. So no, I don't think that we should allow nulls there. Not null. Default value? Default would be example at, or email at example.com. This is notorious. I think in the early days, somebody set up example.com in the early days of the internet. Why? Because, well, they wanted to, they just grabbed the domain And then, of course, all these tutorials and all these documents and everything were send it to example.com. And guess what? This guy was getting a lot of stuff, including sensitive information, right? I believe that it's probably changed and he gave it up for the betterment of mankind. Example.com. I think that it's an example domain, right? So it's just sitting there so that it doesn't do anything because it is now safe to put example.com somewhere, right? Somebody else did this. Oh yeah, do not reply.com. And they would of course capture all the emails that were sent out to do not reply. Like they send it out from the CEO from do not reply.com, right? Do not reply.com. And I think that they ended up posting all of the greatest hits that they got out of it. Like somebody, griping out, okay, I am not going to proceed. Probably it's just that their SSL ticket is gone. Sure. Nope. Back away. Anyway, they had a lot of great emails sent out, or noreply.com or something like that. You can sit on those. No, I'm not going to have that default there. Right? Email ID, address, and person ID, and it's a foreign key. Okay, and this is going to be why did I immediately go to not null? Why did I immediately think of this as an integer? Person ID is going to be referring to what? The person ID over here in the person table, which is an integer. Can you compare a string to an integer? Yeah, but are you going to get any get expected results? Hello versus 1, 2, 3. That's not going to match. So we keep these things the same. Okay. We also don't like strings as our primary keys or foreign keys because it gets into case sensitivity issues. Collation issues. Are you using regular old ASCII or are you using Unicode? For example, just this morning somebody posted on the main page that there was something wrong with, I think, case 14 because somebody had generated somebody's name with a diacritic on it, a non-ASCII diacritic. And so it had a bunch of Unicode in there, and if you were doing something that was incompatible with Unicode, it might have broken, so I went in there and removed that character. If you're the one that did it, great, because you're trying, that's called fuzzing, by the way. You're trying to break something by coming up with a bunch of random strings that may or may not be good data. Somebody up in Omaha took this to an expert level. They filled up all of their CSV test data with a bunch of Unicode, emojis, ancient hieroglyphics, all this stuff. They were just trying to break stuff. I commended them because that I said, this is what you don't know it, but what you're doing is fuzzing. You're trying to break code by sending it bad data, right? Anyway, person ID not null. There is no connection between this table and this table yet, unless I specifically put in a foreign key, and that's what I'm going to do now. Foreign key, person ID, that refers to this column in this table. References, person, that refers to this table down here. And within that table, it references the person ID in that table. There we go. Parentheses are important. Right? Again, this is a foreign key, that references this table and this column in that table. Okay? Let me go ahead and try to execute this all now. Nope. That's from the last section, so drop table not drop database cvert. You can do that if you want. Make sure that that's absolutely what you want. I'm deleting every single table in my entire database. Right? I'm fine with that because I've got backups everywhere. Create database cvert. Once you've deleted your database, you do need to recreate it. Right? And then you need to use it. There we go. Now we're starting with a fresh database here. Let me go ahead and clear this out. Execute it all. It immediately errors out with that red X. Can't create to email table because it incorrectly references a table that doesn't exist yet. Can I create the email table, which references the person table, before I've created the person table? Nope. Just like structures in C, order matters. So you can create the person table first, as long as you create the email table second. Let's come back. Oh, I don't want to save. Sorry. Let's come back over here to our this example here. How would I have had to create the tables? Remember, you can't have orphans. That you have to have a parent before the child. So what order would I have created these tables in? Publisher, then game, right? Parent, child, then availability? Nope. Platform next, then availability last. Okay? Now when I do this, I can go ahead and get a successful 2 green check boxes, or check marks. If I did it a second time, it fails. Why? They already exist. Right? Well, that kind of sucks if I go back in and say, oh, I misspelled something. Date of birth, or birth date. I've changed my mind. I want birth date instead of date of birth. Right? Can't do that without first deleting them. Drop table person. Drop table email. There we go. And those do require semicolons. Can I delete them in the same order that I created them? Let's come back over here. If I created the publisher first and the game table second, just focus on those two. What order do I need to delete them in to ensure that I have no orphans? I need to delete all the children and then delete the parent. So if I delete the person and the table, right? There we go. Then I need to delete the email person table first, and then I can delete the person table. In other words, reverse order. Right? I don't have a better term to use here, folks. This is what they call it. It's not my term, right? So, execute it all together. Oops. So, dropping it twice, can you do that? Drop the email table, drop the email table, do this over and over again. I'm getting an error. It doesn't exist. I can't do that for you. It doesn't exist. And then at that point, it errors out of the entire script. If you want to do this, you can do it conditionally. Drop table if exists. Right. Drop table if exists. And yes, you can also do create table if exists. Does that make sense though? Create it if it already exists? No. If not exists. And again, it's not my choice, bad grammar. If it does not exist, right? If not exists. If not exists. There we go. And now let's clear this out and run the entire thing. There we go. I do get warnings. I get something new here. I get warnings that you can't drop something that doesn't exist, but that's perfectly fine. They're just warnings, and it moves on with its life to the next line. Warning, warning, then green check mark, green check mark. Okay. There's my first part. What about the rest of it? Come on. It has to re-register. There we go. All right. What about the rest of this application here? We've already decided that we only want one table to rule them all. Right? One single table inheritance strategy here. So let's go ahead and do that. Let's go ahead and make it big because it's going to be a big table. Account. I'm going to put everything into one table. First thing I should do, though, when you make any table is what? Oops, sorry. First thing is primary key. So account ID, primary key, not null, auto increment, and this is an integer, int. There we go. Okay. Now let's go to our actual UML diagram over here and see what else we need to put in. What else do you see? Let's start at the top. What do all accounts have? An account number. But here it's a string. Oh, maybe I should go back here and change my my choice of primary key to a string and use account number. Not a good idea because of case sensitivity issues, Unicode, whatever else you might have, right? Not only that, but there's a difference between what's called a natural key and what's called a surrogate key. Right. So a natural key is, for example, people. How would you uniquely identify somebody in the United States? Social Security number. How would you uniquely identify somebody here at the university? An UID number. These are natural keys. Now, do you think in the history of the Social Security office or in the history of UNL, nobody has ever screwed up? They've been perfect the entire time. And they've never issued the same NUID number to two different people. Or screwed up and issued two NUIDs to the same person. Do you think that we're perfect here, right? No, right? Do not trust these. These are natural keys. In other words, they are outside of our system. We do not have any control over them. If we don't have any control over them, they shouldn't have any control over us. Yes, I agree. We should put this in here. Account number. As a string, so varchar. And we should make it unique. I don't know, does anybody know that symbol? It's not the @ sign, it's the U with a circle around it. How common is that? Anybody seen that before? All right, nobody was ever in debate? No? Okay, we use that in debate all the time. Uniqueness, right? With a circle around it. Just checking. Ancient debate stuff. All right. Anyway, unique, where I'm going to want that to be unique. I'm going to want to treat it as a natural key though. Yes, I'm going to go ahead and put it in here. I'm going to store it, and I'm going to make sure that it's unique. But I'm not going to let it control my database. I'm not going to let it control the uniqueness of this record, its relationship to anything else within my database, right? Because what if somebody does screw up and issue the same NUID? What's going to happen? I'm going to have to come to my database and change that table and that table and that table and that table and make sure that that table is now connected to that table. I'm going to have to change my entire data model. Whereas, if I keep it in one column, in one table, and I don't let it control the integrity of my database, oh, somebody screwed up and issued this, NUID needs to change. Okay, I'll go ahead and update that one value in that one record. Right? All good. Surrogate keys are auto-generated keys like this, right? And that's what you should be using. Okay? Don't use natural keys because you don't control them. Right? If you tried to get like an ISBN to publish a book, first of all, you got to pay them, but then it's on them to make sure that they've never issued that ISBN number before. Right? Another alternative here would be like a UUID, right? Universally unique identifier, which is a cryptographically generated, very, very low probability that anywhere in the world, anytime in the next 4 billion years, will be generating the same number, right? At random, right? Or on purpose, unless they just copy it. Right? All right, what else goes into my account? Monthly payment terms for an annuity, balance, and annual percentage rate for savings. But any annuity account is not going to be using these two things over here. Any savings account is not going to be using these two things over here. So I could go back and reconsider this and say, okay, well, maybe I do want 2 tables, or maybe I want 3 tables, separate everything else out. Otherwise, or I can come back to my single table inheritance strategy, and I can ask, how should I do this? How can I distinguish between an annuity account and a savings account? How are you distinguishing between equipment, products, and services? From your CSV files, I should say. What? In other words, a single character, right? Oops. Type. Varchar. And in my notes here, I'll have A for annuity and S for savings. Right, there we go. Again, this is me whiteboarding stuff, right? You come back, you cross things out, you move things around, right? Okay, well, I want the type down here now. Move it out. I don't want all that, but move things around, do whatever you want with it, right? Take a picture of it, and that's what you hand in with your design document. Okay. Otherwise, those 4 things, which would be monthly payment terms, so monthly payment, years, and these are for an annuity. And what's the other 2? Balance and APR. Balance, APR. And these are for savings. Right? And what types should each one of these be? A year is probably going to be an integer to match my Pojo, plain old Java object. Monthly payment is currency, so double. Both of these are probably going to be doubles. But remember, what's APR? Or I can't draw a star. That's okay. I can put a star. There we go. Star. And this needs to be on the scale of 0 to 1. There we go. Because I'm going to come back and remind myself, can I enforce that? I don't know. We'll find out. Okay. All right. Anything else for the account table? We can always come back to it. We've got a person table and an account table. How do we bring them together? Person. I won't draw out the details here. Account. What kind of a relationship do we want between those two things? Remember, originally, one person had an account, multiple accounts. I had like 4 accounts when I was doing this in Java. But we have this variation now. We want to support joint accounts where I and my wife can have an account. And I can also put my father on it. And I can also put my kids on it, all 3 kids on it, right? So now it's got 6 owners, right? Authorized users, whatever, right? So if I want to support that, what kind of a relationship is that between those two things? Many to many. So many to many. How do we do that? Let's come back here to this example. I have a join table in between there. Right? So to bring those two together, I'm going to have to create another table. And this is a join table. What's going to be in it? Trapezoid. What should I call it, first of all? What does it model? I could get, I could be really non-fancy here, and I could have called this, instead of availability, I could have called it game platform or platform game, right? Just taking the 2 names of the tables and shoved them together, right? What would you call it relationship here? That a person blanks this account is blanked by that person. Fill in that blank. Ownership? Okay. I like ownership because that is a noun, right? Ownable is an adverb, right? Owns is a verb. I don't like any of those. I like nouns. Ownership. We're going to need to bring these 2 tables together here. So that means that we need a person ID, which is a foreign key, to that table. And we're going to need an account ID, which is a foreign key to that table. I left some room there. Why? What's the first thing you do with every table? Just pound that into your head. Primary key and named after ownership ID after the table. Right? The reason that you do this is not only for consistency, but also it buys you what's called second normal form for free. Right? First normal form, email 1, email 2, email 3. That violates first normal form. Second normal form, you get it for free if you make your key, your primary keys just automatically generated for each table. Right? It's not dependent on some subset of the data in the table. All right. What else? Did we have anything else? I don't think we had anything else, but we could put in other potential stuff here, like, for example, open date. The date that the account was opened, right? Others? Who knows? Question mark, come back to it later. Okay? All right. First step is, let's go ahead and put this in with the 10 minutes that we have remaining here. I want to create an account table. Okay? So the first thing I want to do is make sure that I drop it if it exists. Drop table if exists account. So then I can come down here and create it. Create table if not exists account. It's highlighted in blue. Don't ask me why. I don't think that that is a keyword, right? We'll find out here in a moment though. Account ID int not null primary key auto increment. Increment. There we go. Let me go ahead and try running it all. Yeah, it's not. Sometimes it gets persnickety about these things. Account. Why are you highlighting that? Is that account keyword in SQL? I don't even keywords reference. Find account. No, it's not a keyword. Why are you highlighting? I don't know. Don't ask me. Anyway, maybe it's in some variant or something out there. Right. Okay. What else goes in there? Account number. And remember, I want it to be unique here. So I'll show you how to do that now. Account number, which is going to be a string, and you can use the string keyword. Don't varchar 255 say. Not null, and what I'm going to do is I'm going to put in a uniqueness constraint here. Let me look it up. I forget how to do it, dang it. It's just uniqueness, right, unique. Come on, where is it? There we go. Yeah, just unique. Unique key. There we go. You can use one or the other, unique or just key. The reason that you would want to use unique is obvious, because now if you put in two accounts with 1234A, 1234A, it's going to reject that. Why you would want it to be a key is so that it maintains an ordering. So now think back to Computer Science 1 or even their first assignment. Why is ordered sorted data good? Because of searching, binary search. If you put a key on this, that means that internally the database will maintain some sort of ordering so that it can find a value that it's looking for. If you search on account number, if you are ever going to do any searches in your database based on a column, you need to make sure that that column has a key value placed on it. Right? Key does not mean unique. Right? Unique means unique. Primary key means unique. But key by itself just means that internally it's going to be indexed. We call that indexing. In fact, it shows up over here in this ER diagram. It's a static image, but if you'd click this in MySQL Workbench, you could have seen all of the indices that are put in that table for fast lookup. Right? Yeah, we're not going to have time to finish this, and we'll do it on Friday, so might as well look at it. There's a nice little comic on why you do this. Right? So here down at the bottom. Who's this? Commit strip. All right. I have no idea who they are. So, person A thinks, I think we've hit MySQL limits. It's simply too slow. Let's face it. And this is, by the way, like 10 years old. The amount of data is colossal. I was thinking that we should go ahead and switch to NoSQL. NoSQL is a database model that it's not relational. There's no integrity at all. There's eventual consistency. Basically, think of a Python map, storing everything as a map, right? Now there's no relations at all between them. There's no key constraints. There's nothing, right? There's nothing forcing good data integrity. So he wants to switch over to NoSQL. I've prepared a 3-month battle plan. Here, look. Frameworking, refactoring, training workshops, internal tool updates. Wait a minute, let me check something. Just as I thought. Here you go, it's called an index, and it just made your queries 20 times faster. Right? So this is programming humor, right? It's not really funny unless you're steeped in the culture. And eventually, you'll get to know why indexes are a good thing, just like you learn why binary search is a good thing. That first assignment where we gave you 1 million data points, right, between two files. 1 million times 1 million is 1 trillion. Are you going to be doing 1 trillion operations within the next couple of weeks? Probably not. But you can get it done in a matter of milliseconds if you sorted and you use binary search. Same idea with an index. With an index, it becomes not 20 times faster, millions of times faster. Right? Why? Because it can actually use binary search. It's not using binary search, it's using a tree data structure to do it, a B tree, but it's the same basic concept. Divide and conquer. I look at the middle element and it's either over here or it's over here. In either case, I've cut out half of the possibilities. Cut out half, cut out half, cut out half. That means that you are, it's an exponential speed up. Right? By the way, in case you think this is just a comic, it's not. I've faced this at least 2 or 3 times in my career of looking at a database and I'm saying, where the hell are your indices? All right, and something that took a day to produce a report, now put an index on it, and now it takes 2 seconds. Right? And then trying to explain that to somebody of why you do this means that, all right, now we have to go all the way back to computer science 1 and talk about searching and sorting and binary search. Mostly people that have never had formal training. In fact, that's one last quote that I'll share with you instead of doing database stuff here. Let's go to my 3 class here. And where's my syllabus? I'm looking it up a quote, basically. There we go. If you want to be a good programmer, you simply have to program every day for 2 years. If you want to be a world-class programmer, you can program every day for 10 years. Right? Or you can program every day for 2 years and take an algorithms course. Right? The folks that I had to show what an index was clearly had never taken an algorithms course or any formal training whatsoever to see this is why we do binary search. It's the difference between something being instantaneous and something taking weeks or a lifetime or several billion years to compute. Right? And that's why we like indices over here. That one little tiny word. Right? That makes a huge difference. Right? Any questions so far? Otherwise, I'll make sure that this is the notes so that we can pick it up next time.